Гра-та-та-та-та, стреляй, папа, убегаешь от меня, смотришь мне в глаза. Гра-та-та-та-та.
Assalamualaikum. My name is Nohafiza binti Ali, metric number CE190089, and I will present the switchboard panel and its components. Okay, first we have analog meter for current, power factor and voltage. Okay, this is the analog meter for current, which function to measure current flow in amperes. Then this is the analog meter for power factor, which measures the power factor of a transmission system. And then this is the voltage analog meter to measure voltage or voltage drop in a circuit in volt. And then this is the selector switch. Second, which is we have two selector switch, which to control on or off of different current circuit by rotating the handle. Third is the indicator light. This is the indicator light. Indicator light is to monitor and alarm the operation status of the equipment. Then fourth, we have air circuit breaker. This is the air circuit breaker to provide overcurrent and short circuit protection for electric circuits over 800 amps to 10 kiloamps. Fifth, we have heater, switch and indicator. This is the heater, switch and indicator. Its function is to prevent damage or malfunction of electric or electronic components in electrical cabinets. Then sixth, we have kilowatt meter, which to measure the electrical power used over a longer period of time. And seven, we have earth fault relay. This is the earth fault relay, which to protect feeder against faults involving ground. Then eight, we have earth leakage relay. This is the earth leakage relay, which used to sense earth leakage and open a circuit breaker when the leakage current exceeds the preset value. Lastly, we have IDMTL, overcurrent and fault relay, which to protect electrical power system against excessive currents which are caused by such as short circuits and ground faults. That's all from me, and I will pass to my next member. Thank you.
Now, let's take a look at circuit diagram 7.4, which is schematic control diagram for outgoing feeder CW earth fault relay. The operation of this circuit began at the main busbar, and this is the incoming from main busbar. Then it connects to TPN MCCD, which is used as a circuit breaker, and connect to ST. ST is a must when there is a relay. ST is a shunt recoil and it connects to contact. And this is the contact. There is two types of contact, which is normally open and normally closed. And in its diagram, we use normally open. So, in normal condition, this coil is open. If fault happens, this contact will close and connect the circuit, so it will give a signal to the circuit breaker to open. Next, this is a CT. This CT contains primary and secondary, which is purposely for protection. When incoming is 150, when the current goes through the relay, the maximum current is 5 ampere. Next, the numbering in this contact is for the wiring connection. The connection for number 2 is for NS20. And this is NS20. And the connection for number 7 is for ES20. We must follow the wiring connection to energize the circuit. For number 1, we need to connect it with the red line. And for number 8, we need to connect it with the neutral line. Now let's take a look at figure 7.5, which is schematic control diagram for outgoing feeder CW earth leakage relay. The concept is the same, but the difference is this circuit used to trace the leakage current, and the circuit before is to trace earth force. Just like figure 7.4, this circuit begins with the main bus bar, and it connects to the TPN MCCB that used as the circuit breaker. The circuit breaker is connected to the ST, which is connected to the contact. The contact in this circuit is also normally open. When fault happens, it will close the circuit and give signal to the circuit breaker to open. The next stage of this circuit is the ZCT. As you can see, this is the difference between figure 7.4 and figure 7.5. In figure 7.4, we use CT, and in this figure, we use ZCT, that stands to zero current transformer. The connection of this ZCT is in looping concept. We connect the ZCT with 2 and 1. And the connection of for number 7 and 9 is to energize this circuit, which is number 9 connect to the red line and number 7 connect to the neutral.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zulhazri bin Zakaria, AE190019. Will present about the figure 7.3, which is the schematic control diagram for main incoming. Basically, it is known as the single line diagram. It is the single line diagram because it only has the one line. When we install the LVSB, the incoming supply always at above or at the ground to the outgoing at the load, which is at the above, known as the main bus bar. At the incoming supply, it mentioned the 415/240 volt 3-phase and 50 Hz AC supply. So the schematic diagram is the AC supply. It means the 3-phase take down to the single phase diagram. How do we know this is the 3-phase diagram? So as you can see, the labeling RYB means the red, yellow, and blue. So that the RS, YS, and BS is also same, and the ES is the earth is neutral. connected to the ground. After that, you see the connector or the contactor, which is the point to connect the cable to the kilowatt meter. Then you see this is the CTS, current transformer, which labeling 3 times 150/5A. The CTS is connect to the kilowatt meter, and you see this is also have the CTS. For this CTS is connect to the relay. It has 4 units. When it connect to the relay, it must step down to 5A because electronic pipe cannot receive the high current. So it step down to 5A. Before that, you see this is the circuit breaker. The number you see 100. Before that, the line R, Y, B. The number that is show 100 and this show 40. It is the number of the cable which connected to the kilowatt meter. Then from incoming, it will connect to the kilowatt meter, 3 phase, red, yellow, blue. This is the MCB, miniature circuit breaker, and it's for the protection. This one is main supply indicator. Main supply indicator. It has R, Y, B, which means red, yellow, and blue. So incoming from TNB, we can see it indicator at main supply. Once we energize it, the red, yellow, blue will light up, means it have supply from the TNB. Then we have the heater, so immediately we can control, so it will not too wet or too hot. So at above we have the ACB, the A circuit breaker. The labeling shows the 65 kilowatt. It is the 3-phase ACB, and it is also connected to the relay. This is relay. The ACB must operate very well, so it don't have much problem. This is the AS, which means the emitter with the selected switch. The switch is to select the red, yellow, and blue value. It is because the analog, so we must select manually. The same goes for the VS, as red, yellow, and blue. Above we have the bus bar supply, which near to the load, which is the main bus bar. Alright, that's all from me. Thank you.